This video contains Assembly4 basic operation, create sub-assembly, create LCS using concentric, Z-tangent to edge, revolution section, inertial CS, create a new file. Go to Assembly4, create a new assembly. There are parts container containing body or parts for the assembly, and an assembly folder to put all the parts together, and usually also contains a sketch for the mechanism. If I create a body under Assembly4, there will be a default LCS. So this is the default LCS. Under the body, create a new sketch. I can attach the sketch to the LCS of the body. Select Model, select LCS, go back to Task, select Paint Face, OK. If I go to Parts Design, Parts, create a new body, so it will not be inside the parts container of the assembly. Then I create a new sketch on XY plane. There is no default LCS, but I can still use this for creating parts for the assembly. Move this to the parts container. Both bodies are inside the parts container, but this has no default LCS. Anyway, I can create LCS for these parts later. So I can create parts within the assembly or outside the assembly, or copy a body from other files. I can still use it for the assembly. Create a sketch for the mechanism. Under the assembly, create a sketch called skeleton. Select Model, select LCS, go back to Task, select Paint Face, OK. Go to the sketch, create a horizontal line 200 mm. Put a point on the line. Make it center point. Copy the line 4 times. Put horizontal constraint on the line. Draw another line, but no vertical constraint, 200 mm long. Put a point on the line, make it the center point. Copy it 2 times. create another 2 lines. 100 mm. Cover it once. So put them together to form the stairs. Make sure all these have a horizontal constraint. The stairs are completed. So it can be moved like this. Draw a vertical line. (20 mm). Make it 200 from the origin. Draw another line connecting these 2 points. This is for the cylinder controlling the stairs. Extend the cylinder to move the stairs. Check the reference. Now move the stairs to see the range of the cylinder. So the range is from 308 to 204. Create LCS on the skeleton. Select skeleton. New coordinate system. T1. Select this line. Z tangent to edge. The z-axis is horizontal. The x-axis is vertical. Create LCS for the steps. Hide all these LCS. I need LCS for only one hole. Select the circle, concentric. To match the LCS on the sketch, I need to rotate the Z-axis to horizontal. Rotate around the X-axis by 90 degrees. Insert the step into the assembly. Insert. Parent assembly. As I have already adjusted the LCS at the step, I don't need to rotate it when I insert it to the assembly. Now create the LCS for the length on the sketch. The first one, Z, tangent to edge. OK. Create the LCS for the short length. For the length, the board axis is vertical and X is horizontal. So the LCS at the length need to match the LCS on the sketch. Hide the assembly. So the length select the circle, concentric, OK. For the middle one, select the circle, concentric, OK. Orientation of LCS of these holes doesn't really matter, as they are used for inserting screws only. As there are 3 screws per length, there are so many screws and I don't want to insert the screws again and again. So I will create a sub-assembly for the length with screws. Create a new file. Link, create a new assembly. In the assembly, create a new sketch. Select the model, select LCS, go back to Task, select Paint Face, OK. Draw a line. In fact, the length doesn't really matter. I just need a line to create two LCS for the sub-assembly. So I will create two LCS at the top of the line. For the weight, it is for attaching the sub-assembly to the steps. Z tangent to the edge. So the boom Z-axis is vertical. It matches the LCS of the length on the sketch. So the orientation is good. Hide this one. Create another one. Z tangent to edge. I need to attach it to the other side of the step, so it needs to be at the opposite direction. Rotate it around Z-axis by 180 degrees. OK. So there are two LCS at the sub-assembly. Insert the length and screws into the sub-assembly. Insert parent assembly. Use LCS origin. Then insert all three screws. Select the axis. Insert screw. Screw is inserted. Insert the other one. Insert screw. Insert screw. All screws are inserted. So I can insert the sub-assembly into the stairs. Go to the stairs. Hide the link. Insert. Sub-assembly. Parent assembly. Select the one for the right hand side. OK. The link with screws are inserted here. Try the other side. Sub-assembly. Insert. Parent assembly. Select the first link and the left side. As the step is 200 mm wide, this will be minus 200. OK. The length with screws are inserted. I don't need to rotate it when I insert it, because we create another LCS for the left hand side. Okay, so do that for the other two. If you find this video interesting, please subscribe and give it a like. VALCS for the short length. Hide the assembly. Show the length. Select the top circle. Resolution. I use revolution section instead of concentric because with a concentric I cannot rotate it around the z-axis to match the LCS on the sketch, so I need to use revolution section. Okay, another one. For the right hand side, select the bottom circle. Resolution 180 degrees. So it matches the LCS on the skeleton sketch. Or you can rotate it and adjust it when you insert into the assembly. I usually adjust it before if I need to insert the item several times. Select S-length, new coordinate system. For the bottom hole, select the circle concentric. This is used for inserting the screws only, so it doesn't really matter to adjust the orientation or not. Insert the length to the assemblies. Hide the length. Insert short length. Parent assembly. Short length 1. Select the arrow. OK. Insert short length. Parent assembly. Select the left hand side, so still it's minus 200. Y. OK. For the bottom, same. Link to arrow. OK. Parent assembly, number 2, left hand side, minus 200. OK. So now insert the screws. Hide this one. Hide the arrow. select axis, insert screw. The orientation is not correct. So go to the attachment, change angle to 270. So it's correct now. Maybe we hide all those first. Okay, insert screw for this one. Insert. Change the axis to 1 and C to 0. And also need to move in the C direction by 2 mm. It is the thickness of the link. Insert the screw for this link too. Insert screw. So need to take it, rotate it at Y. So change Y to 1, Z to 0, and then 180. Adjust C by 2 mm. Other V-hole will be used for other screws. So the steps: create LCS for the cylinder at the skeleton. Cylinder top. Select this line. Select CZ tangent to edge. Okay. Create another one for the bottom. Okay. Select this line too. Z tangent to edge. Okay. But the LCS are also at this end. So move it to the other end. Go to Map Path Parameter, change it to 1. It will move to the other end. So create LCS at the cylinder. Hide the assembly. So the cylinder. New coordinate system. Cylinder top LCS. Okay. Select the intercircle. Concentric. Okay. Hide the cylinder. Show the walk. New coordinate system. Bottom. Okay. Select the intercircle. Concentric. Okay. So now import them to the assembly. So the assembly. Import, insert, cylinder, insert, cylinder bottom. As the center line of the cylinder doesn't align with the sketch, I need to adjust the distance after inserting the parts. Adjust it at Y directions. 2 mm because of the thickness of the link. Okay. Insert the top part of the cylinder. Parent system. cylinder top. Also need to adjust the distance. It's 8 mm. Okay. Create LCS for the cylinder support base. Go to the skeleton. Cylinder support. Okay. Select this short line. Z tangent to edge. Okay. Hide the assembly. Show the cylinder support base. New coordinate system. Select this edge. Also the edge at the opposite side. Select inertial CS. So the LCS is at the center of the base. OK. Try this one. Import base. Insert. Need to adjust the distance too. Okay, insert the platform. Create LCS for the fold. Hide the assembly. Show the fold new coordinate system. Select the circle, concentric. Okay. And then the other side. Hold one. Concentric. Okay. Another one. Hold two for the connecting wall. Concentric. Okay. Hide the four. So the assembly. Assembly, insert, 4, insert. Parent assembly, select the T1 and then the hole. Adjust the Y direction by 6 to put it at the center. Okay. So basically it's done. So just need few more screws. Insert screw. Adjust the Y direction by 8. Another screw. move it by 3. Also the connecting rod here. Support rod. New coordinate system. Rod LCS. OK. Concentric. OK. Hide the rod. Assembly. Insert. Support rod. Insert. 4. Hole 1. OK. Insert. 4. OK. Create variable. Variable. Hide the LCS. Run the animation. Set 2A to VOA, step size 10. If you find this video interesting, please subscribe and give it a like. Thank you for watching.